So in this video we're going to pull the information from Logger Pro and export it to Excel via cut and paste. So get your Logger Pro file. Here I have some file in the folder. I'll just open one, and when you launch Logger Pro you will see the spectrum come up. I've also launched Excel and put a heading here. You see in the background Logger Pro has launched, and there's the rainbow that is indicative of the SpectroViz experiment. That's the very top is the spectrum for crystal violet, and what you can do is you can click on it, and where you see the handles you can drag it so that you can either enlarge it or decrease it. Also with the table, I've clicked on the handle and I've expanded it. So here you see run 1 and run 2. We're going to take a look at run 2. And what I did was just highlight the graph at the bottom, and you can see that Logger Pro highlights that data set. So what I'm going to do is just pick the data set that I want to copy and paste in Excel. So that's just Command C and then Command T. And here I'm just putting the labels for the different headings: the time, the absorbance, and the temperature. Now what I want to do is take a look at the spectrum and close that so that all I have is the Excel file. I also want to open up another file, and here what you will see is the Logger Pro data set, in which I've done 2 trials for low temperature. So I will probably use this as an example in which I'm going to extract the data and do the analysis to determine what order the kinetics is with respect to crystal violet. Again, I highlight the data set, and here you can see that automatically Logger Pro highlights the data set that is shown in blue. What I'm going to do is I'm going to cut and paste that set into the same spreadsheet, and I'm just going to ignore the first one because you can see that the first data set started with 0 and then moves on. I want to show you an example in which I have a data set that starts somewhere in the middle, and then we're going to 0 the first time. So what you do is you create a column and you write in the command where you take the first data set and subtract it from that data, and then you do a propagation of calculation. So each time is going to be subtracting 781, and here you can see that the second column that was generated now starts at 0. So I'm going to do a scatter plot by selecting the absorbance versus time 0, and I can do that by highlighting the absorbance and then while holding the command highlighting the time 0. Then what I want to do is look for the data in which the absorbance drops to nearly 0, and I can do that by just looking at the data set, and wherever I can see that it drops from, like in this particular case, 0.599 to 0.06, I know that the 0.06 is where the absorbance drop. So I'm going to highlight that, and then I'm just going to delete those rows, and you can see that that's exactly what happened. It deletes the data set in the graph. Now I deleted too much, so I'm just going to go back and undo that. What I really want to do is just delete the 0 absorbance between, say, 0 and 20 seconds. So I'm going to have to look for that in the data set. So right here you can see that I'm highlighting the time where it goes from 0 to about 70, because those absorbance dropped. And what I want to do is just find those rows and then delete those columns. And what happens is that it automatically deletes that data set in the graph, and then it moves all the data set up to where I deleted the row. So I'm just going to go through this and delete all the data set that I don't want in the plot. So again, just select the row, and then if you do option click, it'll give you the contextual menu, and you can delete that. So let me finish this up by deleting the last 2 sets so that the graph doesn't have any stairwell. I have one more to do. And again, it's just a matter of looking at the data set in which the absorbance drops. And when that's all said and done, you'll see that the absorbance that is less than 0.3 has been deleted. What I do is next is I click on the axis, Command T while I clicked, and that contextual menu pops up, and I can change the size of the font. And if I click on the axis, I can get the axis format. Again, Command T will work, and then I can scale the graph so it takes the full page on that graph. Next, I click on the title and name it appropriately. Now this graph right here is absorbance versus time, and the temperature was 14.5 degrees Celsius plus or minus 0.5, and you can see that if you look at the temperature column. What I'm going to do now is generate 2 columns. One is natural log absorbance, and one is 1 over absorbance. Remember that absorbance is proportional to concentration. Then I'm just going to put an equals natural log, and then I'm going to click on absorbance, and I'm going to do a propagation of calculation. And I'm going to do the same thing for 1 over absorbance. Equals 1 over absorbance. Click on J3, and then do a propagation of calculation. The next thing I'm going to do is I'm going to size the absorbance versus time so that it's on the same page, and then I'm going to generate the other graph, natural log absorbance versus time, and 1 over absorbance versus time. Again, you do that by highlighting the y-axis variables first and then the x-axis. That's the natural log absorbance first and then the time. And that then you want to insert a plot and make sure it's a scattered plot. And here you can see the graph that's generated. And then I just want to resize it and then fix the title, change the font, and change the axis so that the graph is taking up the whole page on that display here. So that's just a matter of clicking on the axis and then format axis and then changing the minimum and maximum so that the graph takes the full display in the chart that's generated. Here I made a mistake, and so you can see that the graph is gone, and that's because I chose the wrong axis. So I'm going to go back and fix that and change the format axis, the minimum and the maximum. The minimum should be about 0.8, and then the maximum, that's the top, should be about 0.35. That's minus 0.8 and minus 0.35. And when I do that, you're going to see that the scale adjusts so that it goes the full width. If you look at the x-axis, you'll see that the time is on the top. So I'm just going to get the again, I'm going to do format major axis, and then I'm going to tell Excel that I want that label to be at the bottom right there. Click that and put it low. Now you can see that that axis is at the bottom, making sure it's consistent with the others. Then I'm just going to change the range. The range goes from about 0 to about a little under 600. So that'll change the X scale. It didn't work the first time, so let me do this again. There, finally took it. Next thing I want to do is I want to generate the graph again, except this time it'll be 1 over absorbance versus time. But before I do that, I'm going to fix the size of the fonts here. Again, you can get the contextual menu by either right-click or control-click. So finally, I'm going to generate the graph in which I have 1 over absorbance versus time. And when I do that, I'm going to again insert a chart. It's a scattered. And here you can see the slope on this particular graph is positive, which is what we talked about in class. I'm going to move this a little bit to the side so that you guys can see this graph. Again, I'm going to try and resize it so that all the graphs are identical in size, and then I'm just going to add the proper label and change the size of the font, and then make sure that that graph takes on the full display for that chart. So here I have the minimum at 0 and 3. I'm going to change that to about 1.45, 1.4, and then about 2.5. Here you can see now the graph is taking on the full plot here. And now I can do a add trend line. And the trend line will allow me to generate the equation of a line as well as determine the correlation factor, so I can see which graph is best in fitting a straight line. So I do that by clicking the points, control click, and then I'll get the contextual menu. I want to display the equation. I want to display R. I don't want to set this to the intercept. And it's going to generate a graph, and when an equation and when I click on that equation, I can change the size. Same thing for the natural log versus time. Control click the data points, do a linear fit, and then click on the equation that's generated and change the font so that it can be displayed. Then I'm just going to move it so that it's clearly shown. Finally, the last is the 1/over absorbance versus time. Again, I'm going to add a trend line. I'm going to set the equation and R squared, and then I'm going to change the font so that it's clearly displayed. So these are the correlation, and you can see that the first absorbance versus time is 0.9909. 1/over absorbance versus time is 0.9989, and the second was natural log absorbance versus time, and that's 0.9989, and 1/over absorbance versus time is 0.9973. So what you want to do is, among those three, which one has the best fit, that's going to correlate to the order of this reaction. Next, what I've done was I deleted all those graphs, and I actually copied the previous sheet, to a new page. And what I'm doing is I'm just randomly selecting about maybe a dozen or so data points that's evenly spread out. I'm copying and pasting it because I want to show you how to generate, again, the same plot, same graph, but now not using the full data set that was generated, but just selecting a few by copying and pasting. Next thing I'm going to do is I'm going to consolidate these data points and put it together. So here you can see that I just copy and move it so it's bunched up. And then from here I'll generate a graph. similar to what we did in the previous discussion, except now this graph will just have a selected few points. Once I select the points that I want to graph, then what I can do is do the same exercise as that I did just previously and start plotting absorbance versus time, natural log absorbance versus time, and 1 over absorbance versus time. So what I'll do here is I'll just delete that, and then I'm going to give these proper heading. Oops, that's incorrect. That actually one of these should be, the first column there should be temperature, absorbance, natural log absorbance, and 1 over absorbance. Now that I have that, let me go ahead and generate the graph of absorbance versus time. I'm going to insert a chart, and it's going to be scattered. And here it is. Again, you can see that there are less points from the other one, and that's because we only have about 10 data points. What I want to show here is that selecting a few data points versus selecting the whole data points that you generated will pretty much be similar in terms of the correlation factor, the slope and the intercept. So again, I'm just generating this graph and I'm putting it down here so that you can see all three. Finally, I'm going to generate the graph of 1 over absorbance versus time. And then I'll go ahead and fix the title, the font size, and making sure that the natural log absorbance versus time, the x-axis has the proper display that's towards the bottom, not at the top. So what I did next, I didn't actually fix the font, I just generated a trend line. But you already know how to fix the font from the previous discussion. So what I want to show here is that when I do the trend line and I generate the equation and compare the correlation factor in which I just have about 10 data set versus one in which I've probably had about 80 to 100 data set, the correlation factors are pretty much very close to each other. So here are the three correlation: 0.9909 absorbance versus time, 0.9991 natural log absorbance versus time, and 0.9975. That's 1 over absorbance versus time. And if you compare that to one in which we use the full data set, you'll see again you come to the same conclusion as to which one is the best fit. And depending on whether it's absorbance versus time, natural log absorbance versus time, 1 over absorbance versus time, you now know the order is 0, first, or second with respect to crystal violet. So I got everything pretty much all scaled in terms of the size of the font. Next I'm going to just change the axis so it shows full display of the graph. It's a format axis command. Make sure you know your high point and your low point, because that'll be the range. Once you figure out which has the best correlation, that order is going to apply for the room temperature, the low temperature, and the high temperature. So what you just need to do is do the same analysis for the room temperature. Remember that I'm doing this from the low temperature. You want to do the same analysis for trials 2 and trials 3 and get the slope from your equation, and that slope is the rate constant. So remember that for room temperature, low temperature, and high temperature you did 3 trials. That means you're going to get 3 rate constants, and you just don't need to do these 3 analysis for each of the trial. You already know the order, so all you've got to do is use that knowledge to generate the graph for the other 2 trials. Then you repeat the whole thing for the other temperatures. And we're almost finished here. What I just want to show you is when I go to a different sheet and look at the graph that was generated using the whole data set, absorbance versus time was 0.9909, as you can see here. And then when we compare it to one in which we just have selected, that too was 9909. Here I'm just labeling my sheet so I know to keep track of what I did. The second one, natural log versus time, that was 0.9991. That's just for like 10 data set. And what you will see here is that when you use the full data set, it was 0.9989. And then for 1 over absorbance versus time, the correlation factor was 0.9975. But for the full graph, it was also 0.9975. Or in this case, 0.9973. So that pretty much is how you take Logger Pro, take the information from Logger Pro, put in an Excel file, and then generate your graph for analysis. You're going to do the same thing for the other temperatures. You're just going to pull one graph from each one of those, a representative. So that'll be these three, one for one temperature, the other one for another temperature. That would be 5 graph.